Okay, coming to analysis of variance, one way we have already seen. Coming to analysis of variance, ANOVA two way, we have a table. By the way, why do we use this analysis of variance? When do we use analysis of variance two ways? And I'm asked about the difference in the variances about two different things. Okay. Anyways, let's see an example for more clarity. Now, what does the ANOVA two-way table has is factor A, factor B. Two different things are there, like machines and analysts, machines and engineers kind of thing. Okay, so sum of squares of A, sum of squares of B. Of course, error also will be there. Sum of squares of errors. Degrees of freedom, as we all know, it's always -1 of the value. H and K minus 1, and then for the error it is H minus 1 into K minus 1. So mean square of A is SS A by H minus 1. Mean square of B is SS B by K minus 1. Mean square error would be sum of squares of errors by T. T is nothing but H minus 1 into K minus 1. Now, the variance ratio I'll be finding for the both values, FA and FB. F test by using F test, MSA by MSC, FB would be MSB by MSC. Usually there is one suggestion here, that is always the ratio of F should be greater than 1. So whichever is greater than 1, that is taken as the numerator. Whichever is greater between MSA and MSC, whichever is greater, that would be taken as numerator. MSA and MSB and MSE, whichever is greater, that would be taken as the denominator. Now coming to the example, when I'll go with an ANOVA two way. Now there are three different methods of analysis, M1, M2, M3. They are used to determine in parts per billion the amount of certain consignment in a sample. Each method is used by 5 analysts. Okay. Now analysts are given on the left, methods are given on the top. Each method is used by 5 analysts, and the data is as follows. He has given some data in a table. Does the results indicate a significant variation either between the methods or between the analysts? The variation, is there a variation in the analysts or variation in the methods, is the question. So how do I solve an ANOVA two-way question? Let us see. How do we solve an ANOVA two-way question is, as always, whenever I'm checking a hypothesis, I'll be setting my null hypothesis and alternate hypothesis. Here, I'll have null hypothesis for A and null hypothesis for B as well. Null hypothesis for A would be that there is no significant difference between the analysts. Okay, that is nothing but I'll always set it in terms of this thing. Mu1 is equal to mu2 is equal to mu3 is equal to mu4 is equal to mu5. What is that? What does that mean? That is, there is no significant difference between the analysts. Okay, that is taken as the alternate hypothesis of A. Now, similarly, alternate hypothesis for B would be mu1 is equal to mu2 is equal to mu3. That is, no significant difference between the methods. No significant difference between the methods of analysis. Okay, this is null hypothesis. Of course, it's an option to take alternate hypothesis. You can take, you need not take, because it's just the opposite. Alternative hypothesis would be H1A and H1B. Okay. How I'll write, just see, no need to write, but anyways, at least two are different. Two of mu1, mu2, mu3 dot mu5 are different is what I will write. Okay. H1B would be at least two of mu1, mu2, mu3 are different is what I will write. Okay. Yeah. So now I'll reconstruct the table with the values. Okay. For reconstructing, I'll be needing just see here. In this table, I'll be needing the column total and all that. I'll be needing the column totals. Okay. So what would be the column totals? I will just write here. 37.2 is this value. 35.5 and 34.4 are the values. Column totals. Now coming to row totals, what I'll have is 21.6, 21.6, 21.3, 21.2, 21.6, 21.4. Now the total would be, I'll call that to be G 107, 107.1 or something like that. Okay. Now this values would be called TI. These are called TI. I'll just square them. TI squared I will do. That will give me the last column. I'll use a calculator to do it. 466.6 I'll be having. 453.69 I'll be having. 449.44. Take 2 decimal accuracy, please. 466.56 is what I have. 457.96 also is what I have. 96 is what I have. Again, I'll take the TI square sum as well here. TI squared sum I'll be taking. It comes out to be 2294.21. Okay. Of course, again, I'll go with the this squares also. This would be called, guys, TI dot squared. This is called, and this here it would be called, the squares, row squares would be called dot J squared. Okay. I'll just write yours just to save time. T dot J squared values are all these values. What are they? 1383.84 from the calculator. 1260.25. 1183.36. Okay. So I'll also be taking here summation T dot J squared value, which would turn out to be 3827.45. Okay. So I'll be using all these values to calculate different things over here. Okay. So raw RSS would be nothing but Yij whole square. Okay, which is nothing but the sum of all the values. Okay, squares of all the values. 7.0 whole square. The last value would be 6.9, guys, whole square. Okay, so this would give me 765.67. Now G, grand total would be normal total. These are all squares. Normal total would be Yi. Sum of all Yi is 107.1, which I've got from the table as well. Okay. Now, correction factor I need to calculate. Correction factor, that would be nothing but G squared by N. It's nothing but 107.1 whole squared by N is 15. In total, 3 rows, 3 columns and 5 rows. So 3 into 5, 15 elements are there. So this gives me 764.69. Okay, again with the calculator. Correction factor I have done. Total sum of SS, sum of squares. Total sum of squares is equal to raw sum of squares minus correction factor. This would be give me 0.976. Whose values are there above? You can just put them and get the value. Now coming to SSA. SSA guys. SSA is nothing but 1 by H summation Ti squared minus correction factor. Okay. So this value would give me something like 0.043. Similarly, I'll be calculating SSB, which is equal to 1 by K. Of course, H and K only I think I have taken. Yeah. 1 by K. This is T dot I square, I dot squared, T dot J squared minus CF is what I will do it, which I will get it to be 0.796. Okay. So error also I should find. Na? SS error also I should find. How I will get error? TSS minus SSSA minus SSSB. This value would give me 0.137. Okay. Now I have all these three values. Next, what values I'll be needing? I'll be going ahead with them. What I'll be needing is MSA I'll be needing, guys, which is nothing but SSA by H minus 1. MSB also I'll be needing, which is SSB by K minus 1. Okay. And then remaining things. I know the values. So finally, I'll be calculating FA and FB. Okay. This value, I'll be getting it to be 0.0108. This value, I'll getting it to be 0.3980. Now, there's one more value. There's one more value that I have to calculate. That is nothing but my MSE. MSE I have to calculate because I have to MSE. That would nothing but be SSE by T. T I know what it is. Okay, H minus 1 into K minus 1. So this value turns out to be MSE turns out to be 0.0171. So FA is nothing but MSA by MSE. FB is nothing but MSB by MSE. Okay. So this value turns out to be 0.0, which this is less than 1, and this value turns out to be 23.27. So how do I conclude? Just see here. Now coming to the tabular value of F tabulated value. Of course, let alpha, I'm choosing alpha to be 0.05. Okay, because nothing has been given, 0.05. And this is nothing but 2,8. Okay, the degrees of freedom of A and B. Okay, right. Now, this is equal to 19.40. So, what do I conclude? Since calculated value FA is less than 1, it is not significant at all. So, we fail to reject the H naught. That is, we accept the H naught. That there is no significant difference between the NLS. Okay. So, now FB is 23.27, which is greater than the calculated value. So we reject H naught and accept H. With H, 1A, 1B I'll be H naught and H1 we will say, na? Okay. So I will just write here. FA is less than 1. So we accept H naught. We accept H naught. Okay. FB is equal to 23.27 greater than F tabulated value, which is equal to 19.40. So we H naught A I am accepting, H naught B I am rejecting. We reject H1B. I'm sorry. H naught B we are rejecting. H1B we are accepting. Okay. So what we'll conclude that they differ significantly. Okay. At 5% LOS. Okay guys, that's how I'll do a problem on ANOVA. I'll stop here.